So, still continuing the development of my chat application. And today I want to tackle on long polling. So, I told you on the last video that I wanted to talk about long polling today. And, well, you can look at the internet if you want to know what long polling is. I'm not going to read this, of course, right now. I'm just going to go and implement it. So, first I want to say why I want to do it. So currently, the way that messages are polled for in the server is like this. So every 1 second, the front end is performing a request to the backend, as you can see here. What is the problem with this? Well, the problem is that once I send a message, for instance, hello, you see it takes a while to show up. So even my message, this is because the way the front end here works is that the front end is not adding this message that is being sent here. It does not add this message here. Instead, it sends the message to the backend, and the backend, and then when it's polling the backend for new messages, the very message that this user sent is gonna come back through the polling request, and then it's gonna be added here. But anyway, it could also be easily demonstrated with just 2 separate sessions here, and I open an anonymous session, so I have separate sessions. So John secret. If I send a message here, you can see it's not going to be instant. So I send it, and it takes a while, up to 1 second, to show up. That's because the timer is set up for 1 second. So here in the front-end code, you can see that there's this set interval thing, and every 1 second, it will show the message. So in order to improve that, I could just reduce this to 1/10 of the value, which is going to be 10 times per second that the front end is going to poll the backend. And I have my Webpack running. So if I refresh this, I can see there are way more requests right now. And also here, let me refresh this. So now if I send a message, it's gonna show up really quickly. So it's gonna have the impression that it's instant. If I reduce this further, it's gonna be even more instant. But what are the problem with this? Well, the problem is really that the server is getting hit quite often by a lot of requests. And if you take a look, most of the requests are just returning nothing, just empty array. So all these requests here are returning empty array. That's because there are no new messages every 100 milliseconds in the chat application. Usually when you're talking to someone, you're not sending 10 messages per second. Even if you are in a chat room, it's not so many messages out there. So the thing is, we want to solve this. I want to solve this. Not good. So this is going to be way too overwhelming to the backend server, and then we would have problems scaling this application. So one solution for that, so there are many solutions out there. One solution for that is using long polling. So long polling is quite an old thing. I wouldn't say it's a new technology, and even newer technology would be to use WebSockets for that. So WebSockets would be a good solution. However, I want to do long polling for now because I want to explain that concept. And then we do WebSockets. I can't pronounce WebSockets. And then we do it later. So how does it work? Well, the first thing to change is in the front end. So let's go, and instead of performing this on every interval, the way we're going to do this is we have to change it a little bit. So I'm going to comment this. We won't need, well, I can delete this code. We're not going to need it. So I'm going to create a new method. So this.checkNewMessage is going to be like this.poll for new messages. Poll for new messages. I'm going to create it here. And this one is going to call, so this is going to call this one. And that's it. So we're ready to go. No, I'm just kidding. So I have to change also this function here. I want to change it to Then on finally, I wanna return here a promise, and actually this is already a promise, so I can just hit return there. So fetch returns already a promise, and I wanna use this. I wanna leverage this. So this dot check new messages, and then I wanna do, so once it's finished checking for new messages, I'm gonna do finally we can do something. So what is finally? So finally is like then, but it's called on both cases. So it's called when the when the promise resolves or when the promise rejects. So it's always called. And I don't care if the promise is rejecting, I just want to check for new messages. And whenever we are done checking new messages, what we want to do is that we want to once again check for new messages. And then I'm going to use set timeout for this with a timeout of 0. Actually, I don't know if I can just go, what would happen if I would just do like this. I think it would just work. I think I don't need this timeout. I'm going to use the timeout for now, and maybe I'll remove that later. But the idea here is that whenever this request is done, is already going to go ahead and call it again. So of course, this is much faster than using a timer. And if I refresh it now, it's gonna be crazy. Well, it's gonna be crazy if I call it. Well, I'm calling it. So I'm calling it here, and then I'm calling it here, and then finally it's the wrong method here, so I want to call myself again. So this is going to be kind of a loop. Well, it's not going to be kind of a loop, this is actually going to be a loop. So you can see it goes like crazy. I think I can remove this set timeout. I think there's going to be no problem here. So let me do it like this. Cool. I think if I do it like this, I'm going to affect the performance of the, I don't know why I restarted it backend. I think if I don't put the timeout, I'm going to affect the performance of the front end. So that's why I put the timeout. Or maybe I'm calling, once again, I'm calling the wrong method. Yeah, I don't know. I don't see any issue. But anyway, let's do it like this without the timeout. So this, so it's going to be like this. It's going to be performing a lot of requests. And then you ask me, why? Why are you doing this? And the answer is because, so this is much worse than it was before. And the answer is because I want to now change it on the backend. So I refresh this so I can get rid of all these HTTP calls. So now, what about long polling? So the difference is that poll, this method always returns immediately, meaning that whenever you call it, it's going to return something immediately. It's going to be very fast. And we want to change that. We want to change that so most of the times that this get called, it is instead of returning immediately, it's going to return like it's going to wait like 30 seconds or so. And yeah, so we're actually going to make this method much more slower than it currently is. Yeah, so the idea behind long polling is that there's gonna be a loop. There's not the optimal way to do this, but I'm gonna start with this and then improve on it later. So I'm gonna say messages equals nil. That's because I wanna take out these messages here, this variable here, and I put it outside of the scope of the loop. So I just have to declare it somehow. And I'm gonna say iteration equals 0. And then it's gonna be a loop. So what the loop is gonna do is gonna check for new messages on the database on Redis. And whenever there is new messages, the request is just gonna finish. It's just gonna return the new messages. But if there are no new messages, so if messages here is empty, then what we want to do instead of returning right away an empty array, what it's going to do is that it's going to wait. It's going to wait. So that's why it's called long polling, because it's going to take a long time. It's a long request. So the request, instead of finishing in like 10 milliseconds is going to finish in 30,000 milliseconds or more than that. So the idea is that it's going to be an infinite loop, but it cannot be infinite, of course. We have to return at some point. But if the messages is empty, this always gets me in Ruby. So if, and I'm gonna negate this. So if messages is not empty, then we break out of the loop and just go here and return the message. So now let me replace this with unless. And well, we cannot do this forever, so we gotta put some limit there. So let's do like iteration. I don't know if Ruby has this. Anyway, I'm gonna do like this, and I'm gonna say that if iteration is greater than 10, let's say 10, then I'm also gonna break out of a loop. So that's how it's gonna go. So if messages is empty, it's gonna return and it's gonna answer or respond to the request. Otherwise, it is gonna go and increment this iteration. And if we hit the maximum number of iterations, which here I'm saying 10, then what's going to happen is we are also going to break, although we are then going to return a empty array here. And the next thing to do here is to put a sleep. So it's going to sleep 1 second. So if I am hitting a limit of 10 iterations and each iteration I sleep 1 second, that means this is gonna be roughly 10 seconds, roughly. So let me run the server and put like here, and now gonna refresh. So what is happening now is that there is this, you see there's a pending request here. So this request is pending. You see here on timing. So yeah, this was finished now. So this request for new messages, it returned empty array, and it took 10 seconds. So the whole request took 10 seconds. And you see this last request here is also is not finished, and you see it took 10 seconds as well. And now I did this request. So what is happening is that we are on that loop, on that infinite loop here on the front end. However, we are not going right now we are not going as fast as possible. We are going slowly. And who controls the speed of this is the backend, not the front end anymore. So the backend is waiting 10 seconds. You see all these requests, they took 10 seconds. So why this? And for the sake of showing something, let me put this leap a little bit lower than this. So I'm going to put 0.1. And then I'm going to increase the number of iterations to 100 so that 100 times 0.1 is still 10 seconds. So or restart the server. There we go, waiting for a restart. It has to wait for this request to finish. Yeah, let me close this because then the server goes out. Now I see it's weirdly performing like 4 requests. Do I have? Yeah, I have this here. So shame on me. Let me. Oh, I didn't want to close that. So I have a problem here. My server is not stopping. Yeah, there you go. So let's put it like that. And now we are still gonna see the same behavior. So nothing changed really, right? Nothing changed. If I log in now with a different session over here, and I go to username and I put John and secret and log in, what is going to happen is that the messages right now, they're going to be much more instant. So when I send a message, send an instant message, I am. So there you go. So this message, it came duplicated. So that's a bug definitely. But the idea is that now it's much more instant than it was before. Then before I'm going to do it again, and you're going to see it's already here. So yeah, this is probably some bug on the Well, probably on the front end, probably what's going on is, well, check new messages. And then I think there's something weird going on here. Poll for new messages. Finally, and it's calling this. What if I put then here? Process message response. I don't know. Yeah, need some time to debug it there. But if I refresh, you can see that the messages are not duplicated anymore. So what's with long polling? Now we have a solution for our chat, which was slow. And let me go to the database and clean these because there are way too many messages right now. So Redis CLI, database number 14, FlushDB, and then refresh here, refresh there. And what's going on? Why is this taking a long time? You see there's a problem there. Yeah, there's definitely a problem. And I'm going to explain it later. So, well, how about now? Well, see, it's instant. Although there's this bug. I don't know why it's there. I don't know. I was using before to test this. I was using this set timeout thing. So maybe that's it. This check new messages, poll for new messages. Yeah, I'm gonna put this set timeout. Maybe that's the issue, isn't it? And cursor, what happens there? Poll for new messages. Maybe it's too fast. What about being too fast? Yeah, I think I'm pretty sure what's going on now. I think something is. I have to do it like. Let me change this to then. I just need to fix this bug. And then instead of doing return here, I'm gonna do return new promise. It's gonna be either resolve or reject. Although we're never gonna be rejecting this one, I guess. And if I do it like whenever, so process message response. Yes, the problem here is that the latest cursor is being updated after this. So this is being called before this is updated. So I wanna have this, I wanna process this, and then after this is processed, then I wanna resolve this. Or I also wanna resolve this, and I'm gonna do it reject. I'm gonna do it resolve. I don't wanna do it reject. Because if it happens to be rejected, then our loop is gone and the chat is just gonna crash. It's gonna silently crash, which is even worse. So yeah, servers here, serving requests. And there's this slowness, but anyway, let me send a message. So send a message. You see, it's instant responses. That's because you can see the polling request. You can't see it now, but it's gonna come up in a while. So once I send this message, there's already gonna be a new one here. That's because we hit in the backend here. When I send them a new message, this condition became false, so message was not empty. And then that request that was waiting inside this loop just returned. And that's why now the chat is much more instant than it was before. Now, what is the problem with this approach? There's always a gotcha, right? There has to be a gotcha. So you can already see some of the problems is that sometimes I'm refreshing here and it's taking quite a while to return the page. So why is that? Well, that's because since we have a busy request, we are hitting a maximum, kind of the maximum capacity of the server. So on last video, I installed the Puma web server, and that was because of a reason. And the reason is that I can better control the resources that the web server is gonna use. So to start the server, I use this command over here. And in fact, you can do BE, and BE is bundle exec. So it's short for bundle exec. And you can do bundle exec puma help, and you're gonna see the parameters, and you're gonna have these threads here, threads. So that's how many threads we have. So what's going on is that by default, so if I skip this parameter, by default Puma is gonna have a maximum 5 threads. And then if I hit refresh here, it's putting 1 request here. And if I hit refresh here also, it's gonna put 1 more request that is, so you see, I opened 2 tabs here, 2 tabs. So these 2 tabs, each one of them, it's performing a request to the polling endpoint. So it's doing it all the time. So every tab or every session has exactly one request to poll at any given moment in time. If I now, and remember that this request takes like 10 seconds, like literally 10 seconds. So if I refresh this page, now that JavaScript executed and there is a new request executing on the server, and it's gonna take 10 seconds. And if I keep refreshing again, so when I hit refresh, that request that was in queued in the server before, so it is not stopped. So the server is still processing that, and it's taking like 10 seconds to process that. So if I refresh this like 5 times, and I have here 5 threads, so refresh, 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 and now it's already going slow. And it's going slow, and if I open it again here, you see it's gonna take a while to load. So this is because this request takes 10 seconds, it very quickly fills all these threads. So all the 5 threads are busy, and they are busy within this loop over here. So that's the problem with long polling, is that you're gonna use quite a lot of resources from your server. So here is 5 threads. I could just go and increase that number. So let me close the server, and it takes a while because it waits for all requests to finish. There you go. So I can increase the number of threads by passing something like this. So I can put like 100 threads. And so this is the minimum amount. So it's going to be 1 thread at minimum, could be 0. And the maximum is going to be 100. And then Puma is going to choose the number of threads based on the demand. Now, if I now refresh this and refresh this. So, okay, it's going. And if I keep now refreshing this, I'm never going to be able to hit that. So now it's working. You see, now it's working. It's working nicely. And the reason for this is now that we have 100 threads. So to illustrate that, let me close the server and open my my thing here that shows my processes. So here's Ruby, and it's gonna be, it's gonna go off soon. So I'm gonna open it here, and there's gonna be 10 threads. So you just fire Ruby and it's already 10 threads. And then if I refresh this, it's still going to be 10 threads. And if I refresh this, also going to be 10 threads. And then let me see if the update frequency, very often. So if I keep refreshing this, now I'm putting more threads to work. You see, 30 threads already. And from the speed I'm hitting refresh, it reached 50, and it's probably not going to grow much more than that because the requests take only 10 seconds. So when a request finishes processing, it gives space for the next one to finish. So if I refresh more often, more quickly, I'm probably going to hit that limit of 100 threads. 75. Yeah, there you go. So it's already taking long to load, and now it's, I'm gonna have to be very, very quickly here. So do a lot of refreshes and then open a new tab, and you can see it's already waiting. And we see the number of threads is 106. it's not going to go further than that. So, and it's not going to go down either because Puma is not going to release these threads, at least not now. So it's keeping the threads there for if there's demand for them, then they're going to be used. And if I close the server now, so let me wait it to finish. Yeah, takes a while. So you see, what also goes up a little bit is the memory usage. So the memory usage with 12 threads here is 42 megabytes. And then refresh. And then if I refresh often, it's gonna create more threads there. Yeah, I cannot refresh too quickly because otherwise the JavaScript does not have time to run the request. Yep. I don't know, it's not working right now. I don't know why. But if I come over and I just do this request via a CLI, I will be able to see that. So I can do this, and I need the port. So HTTP localhost 47. So this request is gonna be instant. The problem is not this request. The problem is this one, and I need to get this number. So this number is gonna give us a long request. And if I keep an eye on the activity monitor, which shows me the threads and stuff, and then if I increase this, and now I want to do something crazy, which is gonna divide this up in 1, 2, 3, 4, 5, 6, and then now we have 12, and now we have 24 terminals, and I can send a request. So now the number of threads is 9, and now it's gonna go crazy up. So 43 megabytes, and if I do the request all at once, it's gonna be 31 threads and 44, 45. So my app is really small, and for a small app, the memory footprint does not increase a lot. But imagine you have a big app, depending on what it's doing, also is gonna use more RAM, and also thread usage is gonna use resources from the computer. So you probably don't want to, and I want to do it like this now, because then I can run even more requests. So I'm gonna do this, and then again, and again, and again, and again, and again. So 30 threads. Now it should go way up. And why is not? Yeah, there you go. Update frequency. So yeah, memory usage is increasing, thread usage is there. And with just 100, you imagine it's just 100 people connected to the chat is already taking this, and yeah. So I think this explains my idea. So yeah, that's the problem with long polling. And let me close this. Oh, look at that, quite fast. Flush database and start. So yeah, I couldn't. We can't just increase this number to a, I don't know, infinite. But yeah, every connection is gonna consume some resources. But I'm not gonna worry right now about that, because there are ways to make this work. But that is then a scaling problem, and I don't want to dig on that. At least not right now. So so yeah, this is a very basic way to do long polling. We could increase this value to more than this, but there's still a problem here I want to solve. And what is going on here is that every 100 milliseconds, this code is going to Redis and asking Redis whether there is a new message there. So this is there's a better way to do this with Redis, and it is by doing, yeah. So let's go to it. So Redis range messages. Sorry about that. I should think a little bit. So Redis has this primitive called, let me increase this. Redis has this primitive called Redis BRPOP. BRPOP. So if we have a list on Redis and we want to pop a value from that list, we can say pop. So let's say, for instance, I'm connected here to Redis and I can make a new list. So I'm going to go push, and I'm going to make up a name here. I don't know, list MSG probably is a good name. And then foo bar, and then let me see what's on that list. So cooks bar and foo. And if I want to remove the lpop, the leftmost key is going to be like this. So lpop just remove this element and returned it to me. So this is very important that it returned this value. Now the list consists of bar and foo. So if I keep popping, the next one is going to be bar, and the next one now is going to be foo, and now the list is empty, and if I pop, it's going to be nil. So nil all the way. So let me add those elements again to the list. So L push. So yeah, now the list is what it was again. And now instead of using pop, lpop, I'm going to use BLPOP. BLPOP message. I think I'm using the wrong command. Yeah, I need a timeout. I'm gonna put I don't know if this is in seconds or in milliseconds. I think it's seconds. So I'm gonna put 5 seconds. So I popped one thing, and let me pop yet another. So yeah, here I got the cooks element, and this is returning differently than lpop. So this is returning the key and also the list, the list, the name of the list, and also the element that was popped. And then I'm gonna pop again, and the next. So now the list is empty, and if I pop right now with this, it's gonna block. So it's gonna wait 5 seconds. So here's my timeout value, which is 5 seconds. So it's gonna wait 5 seconds, and if in the meanwhile something happens, it's gonna return immediately. So this is kind of a long polling for Redis itself. So if I put here 10 seconds, let me open another Redis CLI 14, and I wanna do an L or R push into message, and I wanna say hello world. So I'm gonna do a BLPOP here, and once I push here, it's gonna return. So Redis, it has built-in kind of a long polling thing. So you see, it's the exact same behavior as the long polling for the web request. So this is gonna wait 5 seconds, but if I push an element before that, it returned now in almost 2 seconds. And if there are messages already there, it's gonna return immediately. Otherwise, it's gonna return with nil in 5 seconds. So given this that Redis already has a long polling mechanism built in, we can leverage that to make our chat application work better with that. So we don't have to keep going every time to Redis and asking it, wasting network resources, wasting CPU cycles. So you can just make Redis wait, and Redis is going to wait in a manner that is more performant than our Ruby code. So let's jump right into that. So let's say every time there is a new message, so let's look at the endpoint that puts new messages in this list. So this is not going to change, it's just going to be our push. And this is pushing messages to the right side of the list in Redis. That means what we want to do is that we want to check. So we want to go and check, and I'm going to now remove this loop because it's not going to be in use anymore. And if there are messages, and then here, let me tidy up this code a little bit. I can remove this because messages equals this, and then we parse the timestamps, and yeah. So I'm gonna do like now if messages is empty. So I'm gonna do an exception for this case. So if the messages are not empty, just gonna return them. Otherwise, what is gonna happen is now we want to block. So we want to block, and then I'm gonna say Redis dot BRPOP. So I'm gonna use BR because I'm using R push instead of L push. So BRPOP from the messages key, and then I'm gonna do it like this. And I'm not sure what this. I have to pass a timeout. And a timeout, I'm gonna say 5 seconds. So I'm not sure what this returns. I have to put a binding pry here to know what it returns. So let me actually open a IRB here requiring Redis, and then I can play with this MSG thing. So I'm gonna do like Redis. So R equals Redis dot new, and the URL is gonna be Redis localhost /14, and then r.brpop. It's gonna be MSG, and the timeout is gonna be like 10 seconds. Let me get this in a separate window. And with this, I wanna, so yeah, x equals this. And now I'm gonna do a R push into MSG, and I'm gonna say hello world. So it's almost 10 seconds. So yeah, so it's gonna return nil when there's no message there within the timeout. And if I push a message, yeah, that's what I thought. So it's returning 2 parameters, returning the queue or the list name, and also the value. So there you go. List name and value. So yeah, that's how you use it. So list name and value. Yeah, I'm gonna just use it like this because I don't care about the list name. So I'm gonna do if message equals nil, if message is different than nil, then messages is gonna receive, and I have to multi-JSON load, and then the message. Let's call this message string, so it's consistent with this one, and then it's going to return. So let's see if this works. Let me run the server. Don't need 100 threads. So let me run it and see what happens here. And now it's empty. Should it be empty? Redis, no, not here. Keys, no, not keys. Lane of messages, it's 0. So yeah, there are 0 messages. So hello world. Now, is this working? I passed the timeout of 5 seconds, so there should be one request every 5 seconds. And yeah, that's happening. Good. So if I send a message, hello world, well, now even the send function is stuck. So I got 2 messages there, and if I refresh, yeah, I probably want to add an exception here. So if messages is empty, now why is messages empty? Oh, of course, because I'm popping the messages. Yeah, so actually that's the first problem. That is the first problem. So this solution is not going to work. I thought I was going to be able to do this one, but yeah. If I send a message, I'm going to be able to receive it. I don't know why this send one is taking a long time. Why is this send request blocking? I mean, let's put more threads here. There's going to be 10 threads and 10 threads. It's going to be always 10 threads. For refresh, yeah. So send a message, send a message, send, and send is slow for whatever reason. I don't know why. And will I always get twice the amount of messages that are there? I don't know. Something is really wrong here with my server. Why is posting a message taking so long? Maybe, let me close this. Let me close this connection. If I put in anything, no. No, I think, yeah, I already know what's going on. And to solve it, so now that's a problem of using threads and stuff. So the first thing I need to solve here is, the problem is that this is a global variable, and this connection is being used here, and this connection is also being used here. So while this connection is being blocked here, so this function call is waiting, this one cannot proceed because they're using the same variable. They're using the same connection to Redis. So that's a problem, right? And the way to solve it is we go to the gem file, and I'm going to add connection pool. So connection pool is a gem. Oops, that doesn't work. Yeah, it's this one. So this is the gem I want. So what it's gonna do, or allow me to do, is to use a pool of connections. So more than one connection at the same time. And to use it, I'm gonna need to change a lot of the code. So let's start and do it. Environment, and then I wanna do and set up DB connections. I wanna have something else here. I wanna have a TTR reader. I wanna have Redis connections, or Redis pool rather, Redis pool. So set up DB connections is now gonna set up the Redis pool of connections. So this is gonna go to connection pool, and it's gonna create a new pool. New, and the size is gonna be, well, this is gonna be the amount of parallel connections to Redis, and I'm gonna say that the timeout is 10. It's 5. 10 is quite a high timeout for this. And the code to create a new connection is exactly this. Well, this code here is ugly. I should remove it. But yeah, for now, Redis pool is being used here. Now this is going to work. However, I'm going to have to change a lot of the code because now the Redis global variable does not exist anymore. And here I want to also require it. So connection pool like that. Now I want to just go everywhere I'm using Redis like this, and the changes that is going to be app environment.instance.redis pull, and then I have to use it like with, and then what this does is that it takes one, so there's a pool of Redis connections, and this is gonna take one of those, use it within this block, and when the block end is reached, it's gonna release that connection back to the pool. That's a very quick explanation of this. So here I have to do the same thing, but now the problem here is that I'm returning something, but that's not actually a problem because I can just do it like this. Yeah, there's gonna be like this. So Redis pull with, and then there's gonna be Redis here, and whatever this returns, this thing here is also gonna return it. So you can just use it like this. And also here, same thing. So I can do it like this, and remove this, and do it like that, and there you go. Now I think here in API, there is also, is there also here? No, there's nothing here using Redis. So that's everywhere you're using Redis. Let me double check. Yep. Cool. So now if I run the server again with 10 threads, and I, well, let me close this, and I refresh, now we're gonna have the other problem. So yeah, you see that this is working, but if I send a message, it's gonna show up there. And if I send another one, it's also gonna show up there. The problem is then when I refresh, all messages are gone. And also the other problem is, well, that one was gone quite fast. So the other problem is that if I log in with more than one session at a time, could be the same user, could be a different user, doesn't really matter. So the message is gonna show somewhere, but we cannot know where. So you see, one time is going there and one time is going here. Look at that. That's because the BRPOP, where is the BRPOP? Here. So the BRPOP, it not only watches for changes, but it also removes one message from the array. So that's a problem, right? And I think Redis does not have, I don't know of any Redis thing to go and watch. Here are all the commands of, yeah, this is not gonna work. Yep. So yeah, that's the way it is. That's what we can do with Redis lists. I don't know of anything better than this. And actually, this will be this. So this will work. In the end, this is gonna work. But the solution is gonna be a little bit more complicated than this. So I want to introduce the idea of channels. So instead of listening to so these requests, they are like this. So they are pull, and then there's this timestamp. So instead of listening to a timestamp, I want to change this, and I want to split this this poll call in two different calls. So it's going to be one call to get all the existing messages from the backend. So that's going to be one thing. And the other thing, a different thing, is going to be to get the like the live messages. So live messages or real-time messages, as you want to call it, is going to be a different thing than archived messages. So I'm considering that all messages that are already there, I'm going to call them archived messages. And that's going to be one thing. And yeah, so you got the idea. They're different things. And the idea is that we are going to use this BRPOP and stuff, but we are going to use an idea of channels. Channel, when I say channel, I mean like channel, like TV channel. Channel like this. So first thing is to go and let's create an endpoint to fetch all existing messages. So well, yeah, let me close the server. I don't want to keep it running. So could store the messages anywhere, but I'm gonna keep storing them on Redis. And I want to do a new endpoint here, which I'm gonna call archive or archived. So this is going to return the archived messages. So all messages so far. And what it's going to do is, so there's going to be no parameter here because it's going to return all messages. So all messages are going to be all messages here. And yeah, then it's going to load all messages as JSON. And it's going to return it. So now let me go and, well, now I don't have, the problem is now is that I don't have any messages. So I don't get rid of this BRPOP because it's not working like it should. Let me add a sleep here, otherwise the front end is going to go crazy making requests. And now let me also refresh this. And let me send some messages. So hello world, hello there. I can't even type properly. Hello there, how are you? Of course, we are not seeing the messages because the code is, well, yeah, the code is kind of working. Kind of working, right? Yeah, sure. So if I go to Redis CLI on database number 14, and I go arrange messages 0 to -1, all messages are going to be there. Yeah, now they all shown up there. That's because we're not removing messages from here anymore. So these messages are going to be the archived messages. I could have changed this to archived messages, but yeah, I'm going to keep it like this, and yeah, should work like that. So now we have some messages on the database, and the get, now I can call the get archived. So whenever I call, I'm going to use HTTP to call it. So localhost port, this port number, /m/archived is going to return me all the messages. And they are sorted. Well, they are naturally sorted. So there is no code guarantees that they are sorted, but they're mostly sorted by time. So this one is the first, or is the most in the past, and this is near the present. So this is the last message that was sent, and that's always going to be like this. There can be some exceptions, but let's work with like this. So yeah, the messages are there on the archive, and what I want to do now is I want to do an idea of a channel. So I want to say poll channel. Well, or I can instead of doing like this, I'm going to say channel ID, and then there's going to be a channel ID, and the channel ID could be anything, could be any string or anything really. And well, I want to do a quick test here. Can I this is going to be params channel ID hello ch, and I want to also print the class name. So what if, yeah, now it's going to be crazy because the front end is going to call this so many times. Anyway, what if I call this poll/0, and there goes string /0 or 100, but what if I call it without parameters? So this is not found, and this is yeah, so I have to pass something, start. So I can use the convention that whenever this is start, it's gonna create a new channel. So channel name equals params channel ID, or rather ID. And I say that if the channel ID is start, then I'm gonna generate a channel ID. And I'm gonna say that it's just gonna be a UUID that's random enough. So it's gonna create a channel, and yeah, I have to also create the channel here. So if the channel does not exist, yeah, actually let me do it a little bit different. So Redis, let me copy this. So I'm gonna check before on Redis. So if there is, and I'm gonna call it like channel, and then I'm gonna use a colon to separate as a separator, because in Redis it's common to use a colon as separator. So if there is such a channel, and I'm gonna call it type, and now I have to know what type for anything that does not exist. So yeah, none, but that doesn't help me with, I have to do that again. Redis new, Redis localhost 14. Oh, come on. Localhost, yeah, URL. So this, what this is gonna do is I wanna know what is the type if I return something for something invalid. So it's not gonna be a new, it's gonna be the string none. So if this is none, so this now means that the channel does not exist. And if it does not exist, I wanna create it. Do I wanna create it? No, I don't need to create it. No, I'm full. I don't need to create it because actually what's gonna happen is that Redis can create things out of the blue. So what I'm gonna do here, is I'm gonna go to that channel and I'm gonna get all messages there. So now I'm gonna use the BRPOP thing. Now I'm gonna use the BRPOP. I'm gonna use it like that. So I don't need this. Yeah, so this is fine. Yeah, so message string and then BRPOP, but then instead of this, I'm gonna use it's gonna be channel, and then the channel ID, and I can say messages. Yeah, I don't know, I don't need those messages, but let's put it like that. And this is gonna return a message. And then what I'm gonna do is to return it right away, like right away. So if there is a message, so if this is nil, then I just want to return status 204, return if this is nil. Otherwise, I'm gonna return multi-JSON, and I want to dump that, but I want to dump a little bit different. So messages is gonna be, I'm gonna create an array just because, or yeah, let's just return one message. And this actually I have to do multi-JSON dot load because this comes as JSON. And then here I can say the channel ID is the channel ID. So there you go. There you go. So what happens now? So this code is done. I'm gonna delete all this because I don't need it anymore. And what happens here is, so if there is no, if channel ID is starred, so the idea is that the first time that the front end performs a request to this endpoint is gonna, it won't have any channel ID. So it's just gonna say start. And then the backend is gonna generate a random channel ID for the front end, which is then going to start using that channel ID from now on. And I realize now, I just realized I need something to start up that thing. So definitely need to set these two like 1. Could be anything. I just need to set this channel ID. So I'm gonna set a key called channel ID to the value 1 because I'm gonna need that later. So whenever, so it's gonna set this. This could have been done here, but I want to do it here for some reasons that I'm gonna explain later. So Redis BRPOP, and this is gonna return this timeout 5. Cool. So whenever there's a new message on this channel, and the idea is that now the server is gonna start whenever there's a new message. So whenever the /send endpoint is called, it is gonna put a new message on this channel. And the idea is that it's gonna go through all channels, and it's gonna so for all channels, it's gonna put a message inside the channel. That's how it's gonna work. And then this BRPOP is gonna get this message for this channel. And then the idea is that every session, so every browser tab or so, is gonna have their own channel, which is gonna be randomly generated by the server. And then whenever there's a new message, so let's go here and change this, because then whenever there's a new message, it is not only going to push this to the messages, but it's also going to push that for all channels. And the way it's going to work is that it's going to say Redis keys, and then we want to enumerate all the channels that are there. So to do that, that's why I have this, I need this key over here, which is going to have that's not a very good idea, but let's make like that. Let's or channel rag. Let's make like this, because So the problem is this would match both of these keys, and I only want to match the keys here. So that's why this rag prefix is gonna help. So I want all channel IDs. So all channels are going to be here, and then I'm going to go through all those IDs and channel ID, and then I'm going to go ahead and put a message there. And the content of the message is going to be exactly this one. So serialized message, serialized message equals this, and then it's gonna push to message, and then it's also gonna push to all channels. So I can actually do it like this. Each Redis BRPOP, no, it's not BRPOP, it's rpush to that channel ID, and there's no timeout. Instead of that, there's this serialized message. So beautiful. Now the idea is that this endpoint is gonna feed. So it's gonna feed the archive, the messaging archive, and it's also gonna feed all the channels. So the messages, this is gonna grow and grow and grow, indefinitely. However, the channels, they are not going to grow indefinitely. Instead, they are going to so it's going to grow the server. So this endpoint is going to grow this, but the front end is always going to come here and do BRPOPs, which is then going to decrease that. It's going to consume those messages from that channel. So that's basically how it works. And now the only thing we need to do is to change the front end code. So let's do that. App view, and the first thing is to catch up with the archived messages. So mounted, we want to do this dot fetch archived messages, and when this is ready, we want to go straight ahead to start the polling for new messages. So fetch archived messages, and that's going to be a method. I'm going to declare it here, and this is going to return a promise, return new promise, resolve, reject. And this will call this, and it's going to be basically this. It's going to be very similar. So once this is ready, it's going to resolve, and the archived is just going to return the messages right away. So just content, process, messages, response. It's going to be an array. Headers accept, get. Yeah, so here is, this is wrong. This should be /m/archived. And then it's going to return all of them here. And after that, we are going to go and check for new messages. So this is not going to be, so we won't have this idea of latest cursor anymore. Instead, latest cursor is going to be the channel ID. So it's going to be this dot channel ID. It's going to be a get, it's going to be JSON, and then here I want to change it. So what is going on here is that there's going to be the channel ID, and yeah. So the channel ID actually starts at start. So that's the initial value of it. And latest cursor is being updated here, and I'm going to change that. So I can comment all this. And also, this channel ID is then going to change here. So this dot channel ID is going to be content dot channel ID, like this. And there's going to be one message here, one message. So we have to make an array, because this is expecting an array. And after it's processed, which is a synchronous operation, then I can resolve, and that's it. Yeah, that's it. So if I refresh, let me see at Webpack, is it compiling? Yes. Let me even rerun it. Start the server, fire the engines, and is it working already? Well, I don't know. So did one for start. Did it pick up a polling? Should be 5 seconds. Did it pick up a channel ID? Doesn't seem like it. There should be one more request here, so I think it failed. I think that failed. So what's happening? Poll for new messages. So it called it. The problem is this extra parentheses here. Yes. but that should not explain the problem. This poll for new messages is being called here, but then start, it returned no content. Oh, I got it. So since it returned no content, this result was never called because this JSON never really finished. So yeah, rather than returning 204 here, maybe I should just return a empty array maybe. Yeah, I think so. That would be better. So just gonna return. Yeah, that's actually this would be a bug to just do this. So message string, let's say like result. But the thing is, if there is a message, yeah, so if message string is nil, just do it like this. Then I'm gonna return, I wanna return the channel ID. However, I don't wanna return any message, which means that it could be that this message would be non-existent. So if this does not exist, we don't want to process this. And now it should work. Now it should work. So we start is pending, and now it picked up a polling ID. There you go. So this is always gonna call the same polling ID. Response is empty, nothing here really, because this didn't finish. Now if I send a message, what if I send a message localhost? I'm really curious to know whether this is gonna work or not. So log in with Alice, or rather with John. They have the same password. Now if I send a hello Alice, it didn't work. So that's bad. Something's up. So send return 204, that's cool. But probably this channel thing is not working. So I would guess that the archive is working. Yes, hello Alice. So the message is here, means it is on the database. And if I list all keys, I can see that the registers are here. So keys, channel rag. So if I do it like this, I think I got it. I totally got it. So the problem is that the problem is here. So this is definitely not returning the channel ID. This is returning the whole key. So the key name and the channel ID. So I'm gonna say m equals, and then I have to do a regular expression to extract. No, I don't need a regex for that. This Ruby. Oh, come on. Yeah, I can just split this key name. So channel ID is going to be the key name, and if I split in with colon, it's gonna be the last one. So the last one is gonna be it. So I can see that because you see this. So this is wrong. Restart server, and let's do some messaging. So hello Alice, are you there? And doesn't work. Why doesn't it work? Polling is happening right there. So let's put our binding pry here. Oh, I think I'm putting on messages, and here I am. Oh no, that's fine. So channel colon channel ID. Well, it seems to be correct. Let me actually go to the database and flush it all. So there are no keys. And if I open it, and there are 2 keys, which are which are the 2. Oh, this is also wrong. No, this is not wrong at all. This is just working. So if this is John, so if John says hi Alice, what happens here is that, okay, it's missing. So there should be there should be another key here called channel, and then this ID, and then messages, and that would come from here, but there is none. And the reason there's none, I already know why there's none. The reason is because if there's a list, so let's say there's a list, rpush, foo, and bar. So now if I list all keys, there's going to be this key called foo. And foo is a list, type foo reveals list. And if I now pop, so I'll pop from foo, there's no such thing as an empty list in Redis. Instead, Redis is going to just delete the key. And if you try to remove an element from an element that does not exist, it's going to just treat it as an empty list or whatever. So that's why the keys are not here, because the messages went there probably, but they also went very quickly. They were popped with this thing here. So how can I know that? Yeah, I know that these 2 requests here, you see all this is 53, and this is 157. So these ones probably popped. It's funny that it seems like they were popped before even this was sent, but this is probably just you cannot trust that logging is in a correct order when things are happening almost at the same time. Yeah, so the messages are going there, and they are being returned here. They are being returned. Now the problem probably is that the front end is not being able to deal with it. So if I type in anything and if I inspect this, I'm gonna see the response there, and there you go, message content. So message is here. It's probably that if that I put there, if this message, if this dot message, does this have a response content type? Oh, that's because of this. Probably that's because of that. So this is then not being resolved. This is never being resolved. Huh, that is funny. I don't know then how the channel ID, well, if this is not being resolved, then how is the channel ID being, how can the channel ID be there? No, that's funny. That's really funny. So let me put a debugger here. Let me put a debugger here and refresh. And soon is gonna stop on the debugger and didn't open the source code. So congratulations, Google Chrome. Yeah, now it opened. So this is, oh, it's so wrong. It's so wrong. I already see it. It's not this. It's content. There we go. There we go. It's fixed. It's already fixed. That was the issue. Then here I have to reload. So reload. And now if I send something, oh, there you go. It's so instant and it works. It really works. There are some problems still, but if you look at it, it's not working. The problem now, you see, is that it's creating a lot of garbage in the database, but this is not difficult to get rid of, so we shouldn't struggle with that. It's going to be quite some code to solve that, but it's not difficult. So long polling working. I can have as many clients as I want, and they work. There are quite some edge cases here that I didn't cover. Like for instance, what if between fetching the archived messages and then polling for the new ones, in this meanwhile, it could be that there's a new message that is going to go into the archive, but the poll is not working yet. So there are some edge cases. It's difficult to reproduce that kind of behavior because you would have to be very fast to do that. But these are problems that should be already solved. But I'm gonna let that to a different video or so. And that's it for this video. So that's how we did long polling. And yeah, catch you next time.